If we're going to do reactions in solution, we need to be able to do stoichiometry on those reactions, right? So that means we have to have some sort of way to measure how much of a chemical is present in solution. And there are a number of different ways that chemists measure concentration. Probably the most common one is molarity. And molarity is defined as the number of moles of the solute, so the number of moles of whatever you're trying to dissolve, in liters of solution. Now, you want to make sure that you've got liters of solution. It's not how many liters of water you're putting into it, it's how many liters of solution you have once you've got everything mixed together and you're all done with it, okay? And I point that out because that's a little bit different from a concentration term that we're going to learn at the end of the chapter. So this is moles of solute per liters of solution. So let's look at a couple of examples as to how we're going to manipulate that definition and work some problems with it. So again, if you've got your sheet that has the sample problems for the videos on it, the first problem on there says a chemist uses 124.3 grams of HNO3 to make 250 milliliters of solution. What is the molarity of the solution? Well, if I'm doing molarity, I have to have moles of solute, so that's going to be the first place I need to start. So I have 124.3 grams of HNO3, and remember we always take what we start with and we put it over 1. And for 1 mole of HNO3, I'm going to assume that you know how to calculate this already because we've done it a lot. If you're not sure how to do it, again, you need to make sure you're asking for help. So 1 hydrogen, 1 nitrogen, 3 oxygens comes up to 63.02 grams of HNO3. So grams of HNO3 cancels out. And when I take 124.3 divided by 63.02, that's going to give me 1.972 moles of HNO3. Okay, so that's my moles of solute. Now, notice that it says liters of solution. This is one where I see students make a mistake quite often, is because most of the time, or a lot of times, the volume is given in milliliters in place of liters. So you need to make sure that you convert that. So the molarity of this solution is 1.972 moles. And I'm going to divide that by 250 milliliters. There's 1,000 milliliters in every liter. So if you take milliliters and just move your decimal point 3 places to the left, you will have it in liters. So 250 milliliters, move the decimal point 3 places to the left, and that's going to give you 0.2500 liters. And when you divide this out, that's going to give you 7.888 molar solution. Okay, I had 4 significant figures in everything that I gave you, so my final answer is also going to be in 4 significant figures. Okay, all right, we're going to do one where we're going to kind of start with some different information. It's still a molarity question, but we're going to have to start with some different knowns in the second problem here. So the second problem says a chemist has 45 milliliters of a 0.93 molar H3PO4 solution. How many grams of the solute did that chemist use to prepare the solution? Okay, so well, what do I know? I know the volume, I know how many milliliters of solution I have, and I also know the molarity. So I know the molarity and I know the volume of solution. So if I plug those into this formula, I'm going to have 0.93 molarity. Liters of solution, it says 45 milliliters. So you take the decimal point, you move it 3 places to the left, and that's going to give you 0.045 liters of solution. And so what I don't know is how many moles of solute I have. So if I multiply both sides by 0.045 liters, and I multiply this side by 0.045 liters, molarity is moles per liter. So here your liters are going to cancel out and you're going to be left with moles on that side, and the liters will cancel out over here. So X when I multiply those two numbers, X is going to give me 0.042 moles of the solute in the solution. Am I done? Well, I would be if it asked for moles, but it asked for grams. So now I need to take the number of moles and convert it to the number of grams. So if I have 0.042 moles of H3PO4, take that and put it over 1. In 1 mole of H3PO4, which needs to go on the bottom, there are 98 grams of H3PO4. So moles cancels out, and that gives me a final answer of 4.1 grams of H3PO4. Okay, two significant figures really in both of the numbers that I gave you at the beginning, so that would give me two significant figures down at the end. Okay, so that's what you're going to be doing today, is manipulating that molarity definition to solve problems using it.